All right. Hello, everyone. I'm Bernd, and today is day 23 of Advent of Code. Today's puzzle was about elves and them moving around. So our input will be a grid, and each position there is either a number sign, which tells us that there is an elf at this position, or a dot, which means the position is free. And then the elves move around and try to spread out, and we're supposed to calculate where they'll end up or how they spread out. So the spreading out has particular rules. So each elf in each round proposes a position, and then if it's the only one proposes to move to that position, they'll move to that position. So the proposal works as follows. First, each elf checks if there's no one around him. If that's the case, he stays. There's no need of moving anywhere else. Afterwards, he proposes the first valid direction. So first they check north, and in order for north to be a valid direction, it's required that all three directions north, northeast, and northwest are empty. If that's the case, they propose one step going north and they propose the corresponding position. Otherwise, they check south, and again, south is a valid direction if all three of south, southeast, and southwest are empty. If that's the case, they go one step south. Otherwise, they check west and east and so on. And then, yeah, as soon as everyone else proposes a direction, the elves check if two elves propose the same position. In this case, none of the elves moves because they can't both be at that position. And then every elf who proposes a position no one else proposes, they move. And then this order of these things are changed. So first is north, south, west, east, then is south, west, east, north, and so on. So there was the first of all, the first option always goes to the back. Yeah, that's it for part one. And we want to do 10 steps and see the corresponding position. So what we need in order to solve this, we need to encode a lot of data from the problem. So we have a positions, which x and y coordinates, which we can add together by just adding the coordinates. We have 8 directions from north to northeast and so on to northwest. Each direction comes with a corresponding vector, that will be a position, and just tells us north, which position or which step corresponds to north, and so on. And then each direction will also have two adjacent directions of each of the main directions. So north, the two other interesting directions are northwest and northeast, and east has northeast and southeast, and so on. And then finally, we want to remember that the order of the directions. So we first check north, then south, then west, then east, and then for the second time, it will be south, west, east, and then north. But it's always this direction and some, yeah, we move some stuff to the back, but essentially the direction, the order stays the same. Okay, in order to solve the problem, we of course need to read the file and split it into lines. And then from those lines, we want to get the elf position. We just enumerate through the lines as well as through the character in each line and check if it's a number symbol. And then if we have those elf positions, we want to do a round. So this will keep track of the proposed positions for each elf. We keep track of a set of positions proposed so far, and then we'll also keep track of the duplicates. In order to do that, we'll need a lot of checks, like if something is in the elf position. So therefore, it's very important to convert this list of elf positions into a set, so we can do the in comparison much quicker. And then we iterate through all the elf positions, and then we first check if the elf position has no neighbor in the elf set. Then the proposed position will be the elf position itself. Otherwise, we go through the 4 checks. Then the check ID will be the first considered plus the check number and moduli of 4. So that takes care of this rotating the order each time. And then the direction will be given based on the check ID. And then we check if the check direction is valid, move from the elf position in the elf set. If it's valid, then the proposed position will be corresponding to this direction. So the proposed position will be the elf position plus the vector corresponding to the check direction. We append this to the proposed positions. And then we also need to check if it's been proposed so far. So if the proposed position is in the positions proposed so far, we know we found the duplicates, we add it to the set of duplicates. Otherwise, or in any case, we add it to the proposed positions so far. And if we found all of those valid directions, we don't need to check any others, so we jump out of the loop. And finally, if none of the none of the 4 directions is valid, we just stay at the same position. That's what we do here. And then, yeah, we have a proposed direction for each elf. So then we need to check which of the proposed direction can actually move, which of the elves can actually move to the proposed directions or positions, and which elves need to stay at their current ones. We do that by just iterating through the elf positions and the proposed positions. If the proposed position is in the set of duplicates, we take the old position, otherwise we take the proposed position. And yeah, that's it. The two functions that's useful there is, for example, no neighbors. There we just check all the direction and if the position corresponding to the elf position and plus the direction is in the elf positions or not. And similar for is valid, we'll need to check three directions. So we need to check the check direction itself, and we also need to check the two adjacent directions to the check direction. And then yeah, if one of them is in the elf positions, then we know the position is or the direction is not valid, and otherwise, if all of them are empty, we know we return true. Okay, with that we can solve part 1. So we just use the lines to get the elf positions, and then we do the following 10 times. We just update the elf position by doing a round, and we always the first considered would always increment by 1. We'll add that. This encoded like this. And then for the solution, we want to know, so there's the minimal rectangle spanned by all the elf positions, and then we want to know how many empty spaces are on there. So we just get the minimal y and minimal x, and the maximum x and the maximum y, and then the area of the rectangle will be given by this term. And then we want to know the empty positions, so we subtract the length of the elf positions. We can run a little test. So both we give them a small example that works, and also a slightly bigger example to test that also works. Amazing. So we can also run it on the test input, on a real input, and it also works out. Okay. So part 2 is very similar. The only thing in part 2 is we don't only run for 10 steps, but we run until no elves moves anymore, and then we're supposed to return the round number of this round when no one else moves anymore as a solution. So can we reuse most stuff from part 1? We again get the elf positions, and then we get the new elf positions by doing one round with the current elf positions. Then we just check if the new elf positions are equal to the current elf positions. We break out of the while loop and return the corresponding round number. And if we run a little test, that also looks good. So we can run it on a real input. That takes about 1 minute, so nothing dramatic, but takes a bit of waiting. But yeah. Okay, I hope you enjoyed today's puzzle. Best of luck for the remaining 2 days, and see you around.